So, isometric projection. This is the most common type of projection within sketching for your design ideas. You need to get yourselves into a position where you can, you've got muscle memory, so you can visually apply a line that is 30 degrees off the horizontal. So if you're not confident with this technique, best thing to do is start with a protractor and then work your way to the point where you almost, it doesn't have to be exactly 30, but if you don't get that, the proportion and perspective of your design won't come out right. So essentially with an isometric view, the easiest way to construct the framework, if you're creating something that's complex, you will get confident enough to create an idea just straight off the bat without having this construction, but to start with you will need that to reference that 30-degree line. So if I create a cube to assist me with an idea, so if we look at a flat pack stool for a student study space. Now before I generate that concept there, I've got my idea in my head. I'm just going to note that down on the side here with my, refer back to that 2D sketching technique. So break this down. And the benefit of doing this before you create that improved presentation and 3D presentation is your idea is going down onto page. You can move on to something else if something else comes into your mind, but it gives you a reference to refer back to when trying to get proportion for that 3D view. Right, so let's take a fine liner to that. Okay. So what we've got there that can help us, there are 4 distinct layers within that design there. So what I'm actually going to do is break this up into those layers to aid me in my sketching accuracy. So you can this links really well to how you would construct the design in CAD. So I'm breaking this down into layers. So we've got 1 there, 2 there, and then we've got the thickness of the top of that stool on the top here. Now, in order to get this correct visually, in an isometric view, if you were sketching a circular profile, it wouldn't be sketched as a circle. Everything, because you've got the 30-degree lines off the horizontal on both sides, it's always going to be an ellipse. And if you're not confident sketching elliptical profiles, here's a good technique to practice. So in the top of your frame, and it's got to be a square, in order to represent a circle in isometric. So divide that top square up into quarters and then sketch in the diagonal lines. Now where the quarter mark meets the external lines of that square, you can put a little mark, and then each of these quarters, these segments here, that will become, this diagonal line is its own entity. So 2/3 out from the centre, you need to mark a point. And then what you can do is just sketch a slight curved line. And what you'll find is you will be able to get a correctly proportioned and accurate ellipse, which circular profile in an isometric view. Now to make sure this really does work well, you need to transfer the lines down onto that second plane, and this can feel a bit tedious, but once you practice this over and over with different designs, you'll find that your technique sharpens up And I actually find this harder than sketching a freehand ellipse now, just because I haven't really done this for a long time. But then what you can do is bring your external line down there, and you've got the solid top for my stool. So what I will then do is, because this has got 4 points of contact on the ground, one of them in the 2D view you can't see, I'll bring that down to the bottom planes, each of those lines, so that I've got something to work off. And you'll notice those two, you can tell I've got the sketch right because those two line up behind. So what I'll then do is divide the bottom plane up, and then inside this you need to refer back to that plane 3, and there's 4 points there that need to go back to these corners on the bottom. And if it helps to start with, when you're sketching like this, you can do these lines with different colour, and that can often help. So if you look there, where this point goes down to here, you wouldn't actually see that line because this one is in the way. Okay, so that wouldn't just be two-dimensional though, so we need to add some thickness to that. So you want a parallel line, that's the centre line of that object, so you need a parallel line either side of that to show the thickness of that material. And again, if you look here, you will still just see that edge poking out. So I'm going to put my radius on that, because anything you would manufacture with a manufactured board would need some sort of radius in order to protect the end from damage through use. So we've also got this feature to add here where I've isolated the 4 contact points on the ground. So all I'm going to do is sketch a line in there across plane 2, and then what I'll do, I've gone a bit high there, what I would then do is just chop that material out, and that would also translate to here as well. Okay. Right, so if I take my fine liner, and then I can use the Sharpie to accentuate the lines where you would have atmosphere behind them. So it's a good idea to get a Sharpie that's not too worn. The end of this one's gone quite round, so it's giving me a line that's a little bit too thick. Okay, and we'll do a bit of rendering in a future video. I think that's enough in terms of outlining that isometric technique and how you can use that to generate three-dimensional concepts. So what you could do in terms of moving on from that point is use some cameo sketching to show how this construction would work. So you would actually have, this would be a cross-halving joint, and actually there's a detail in the top there which I didn't add in, which would be where you would actually see the cross of where those slot in. So there's quite a complicated area of design within that panel that I've visualized. So the way that would look would be angled like this, and they would be two slightly different components. So there would be a shoulder on it to support the top of the stool, but then this bit would be an 18mm protrusion that would go up into the top of the stool. So the top would effectively sit in this area, be that thick. It would sit in this area here. Okay. But the key point there is those two joining together. So you would actually have where your centre line is, line of symmetry through the middle of that. You would have a cutout to enable the other component to slot up into it. So the other component would look the same as that, except the cutout would be at the top there.